Good afternoon, students. Now entered into the end of the topic for gate trains. So now we are entering into the topic called the minimum number of teeth on the pinion in order to avoid the interface. So we have already discussed in the previous classes that in order to avoid interference, the addendum circles for the two mating gates must cut the common tangent to the base circles between the point of tangency. So here we need to maintain the mating. That means there is a common tangent for the base circles for the two gates. One is driving and the another one is driven. So with that there may be a contact of creating the tangent to point or point of tangency. So for that the limiting condition reaches when the addendum circle circles of pinion and the wheel may passes through the points N and M. That is where that is a tangent and the normal. So let us consider t with the number of small t with the number of teeth on the pinion and capital T with the number of teeth on the wheel, and M is the module of the teeth and R is the pitch circle radius of the pinion. So there we already get up the formula, that is R is equals to module into small number of the pinion. So the number of teeth on the pinion by 2. And what is the gear ratio? That is the gear ratio means the minimum number of gate teeth are available on the wheel to the minimum number of teeth on the pinion. So capital G is equals to gear ratio, that is equals to capital T by small t, or otherwise small capital R by small r. And what is the pi? That is pressure angle or the angle of obliquity. So with the diagrams, what is a gear mating diagram or gate trains diagram? From the triangle O1NP, O1N whole square is equals to O1P whole square plus Pn whole square minus 2 into O1P into Pn cos of O1Pn. So O1P means that is the radius of the pinion, that is small r square, plus Pn is equals to radius of the wheel, so capital R square into sine square pi minus 2r into capital R sine pi into cos of what is the angle O1Pn, that is 90 plus pi. So r square plus, that is small r square plus capital R square into sine square pi plus 2r capital R into sine square pi. So by commonly taking the small r square at the outside, so r square into 1 plus capital R square by small r square into sine square pi plus 2 capital R sine square pi by small r. Then again there is a sine square pi is the common element. So r square into 1 plus small r, capital R square by small r square plus 2 into capital R by small r into sine square pi. So by taking into the consideration of limiting radius of the pinion, addendum circle, O1n is equals to r into square root of 1 plus capital R by small r into capital R by small r plus 2 into sine square pi. Then what is small r, capital R by small r? That is called as a Gay ratio, and we can write it them as in the number of teeth. Okay, so O1n is equals to what is r? We already noted that pitch circle radius of the pinion. What is the formula? Small m, that is module into small number of, the number of teeth on the pinion divided by 2. So convert all the values of radius into number of teeth. So m into t by 2 into square root of 1 plus capital T by small t into capital T by small t plus 2 into sine square pi. Let us go for addendum of the pinion, that is a suffix p into m, that is addendum of the pinion, where ap is a satisfactory fraction by which the standardized addendum of a one module for the pinion should be multiplied in order to avoid the interference. So for avoiding the interference, we are creating the fraction at the addendum of the pinion. So for that, we are multiplying with the module. So APM is equals to, what is the previous formula? mt by 2 into square root of 1 plus capital T by small t into capital T by small t plus 2 into sine square pi. But what is the addendum of the pinion? The addendum of the pinion is APM, but from the diagram, what is the addendum? Means O1n minus O1p. Then O1p means O1p is the radius of the pitch circle. So smaller. So what is the smaller means? Mt by 2. So there we are commonly taking it mt by 2 as common. So square root of 1 plus capital T by t into capital T by small t plus 2 into sine square pi minus 1. Then in the left side we are having one module and the right side is also having one module. So by calculating these modules we get AP, that is the fraction of the addendum pinion. Okay, so AP is equals to 1 t by 2 into square root of 1 plus capital T by t into capital T by t plus 2 into sine square pi minus 1. So finally we need to calculate the number of, what is the minimum number of teeth. So minimum number of teeth means there is a small t value. So the number of teeth are on the wheel and the same time pinion, both are there, but what is the minimum number of, in the heading itself we have found that we need to find the minimum number of teeth on the pinion. So what is the number of teeth on the pinion? It will be notated by small t. So for that we need to find the relation with the small t with the capital T or the addendum of the pinion, or otherwise the Gay ratio. Okay, Now, so what is the final formula? Small t, that is pinion teeth, is equals to 2 into AP by square root of 1 plus capital T by small t into capital T by small t plus 2 into sine square phi minus 1. That is equals to, what is the capital T by small t? Equal to capital R by small r, that is equal to what? That is gain ratio. So instead of capital T by small t, we may put gain ratio capital G also. So small t is equals to 2 into addendum of the pinion AP by square root of 1 plus capital G into capital G plus 2 into sine square phi minus 1. Then this equation, what we have derived, will give the number of teeth required on the pinion in order to avoid the interference. Okay, this is the formula, that is small t is equals to 2AP by square root of 1 plus capital G into capital G plus 2 into sine square phi minus 1. Then if it may be the condition, if the number of teeth on the pinion and the wheel, if the number of teeth on the pinion and the pinion and the wheel both are same, so then what is the gain ratio will be 1. So substitute capital G, that is gain ratio, as 1. What is the T formula? Small t is equals to 2AP by square root of 1 plus 1 into 1 plus 2, that is 3 sine square phi minus 1. So the above equation is reduced to like this. Then if it is the case, the number of teeth of number of teeth on the pinion which will meshes with any gear without interference. So without interference, if the pinion is meshes with any of the gear means whatever may be the design of the gear, that is either helical or involute or cycloidal or rack or spur gear, like that. So number of teeth on the pinion, number of teeth on the pinion is the system of gear teeth. Suppose if the system of gear teeth angle, it is 14 and of degrees composite, how many number of teeth will be? 12. If it is 14 and of full depth involute, that is 32, and 20 degrees full depth involute, 18, 20 degrees stud involute, stub involute, that is 14. So like that, these are the direct minimum number of teeth on the pinion in these 4 cases only. Okay, then coming to next one. So in the previously or just now we discussed about the minimum number of teeth on the pinion in order to avoid the interference. Now in this topic, minimum number of teeth on the wheel in order to avoid the interference. So here we need to find capital T. Okay, so mostly the both of the formulas may be the same, so that we will check it now. So let capital T be the minimum number of teeth required on the wheel in order to avoid the interference, and AW, that is addendum of the wheel, AW, that is addendum of the wheel, there AP, that is addendum of the pinion. Okay, which is to be multiplied with what module? So AP into M, here AW into M, addendum of the wheel, where AW is the fraction by which the standard addendum for the wheel should be multiplied. And then using the formula what we have preferred in the previous, that is O1NP, but here for wheel it is O2MP. So if you clearly observe the diagram that we already previously remembered. So from there O2M whole square is equals to O2P whole square plus PM whole square minus 2 into O2P into PM cos O2PM. So that is capital R square plus small r square sin square pi minus 2 into capital R into small r sin pi into cos of 90 plus pi. So both are same. The formula is so capital R square plus small r square into sin square pi minus cos 90 plus theta means cos 90 means sine, that is minus sine. So that already there is a minus 2 capital R into small r sin pi there. So multiply with minus sin pi means minus into minus plus 2 capital R into small r sin square pi. Then by commonly we are taking the small capital R as the common. So capital R square into 1 plus small into 1 plus small r square into sin square pi by capital R square plus 2r into sin square pi by capital R. So r square into 1 plus small r by capital R, commonly small r by capital R plus 2 into sin square pi. So limiting radius of wheel addendum circle, that is O2M is equals to capital R into square root of 1 plus small r by capital R into small r by capital R plus 2 into sin square pi. So what is capital R? That is pitch circle radius of the wheel. So small m into capital T by 2 into square root of 1 plus small r by capital R means, that is we may write it as small t by capital T. So into small t by capital T plus 2 into sin square pi. We know that the addendum of the wheel, it is O2M minus O2P, is equals to AWM is equals to MT by 2 into square root of 1 plus small t by capital T into small t by capital T plus 2 into sin square pi minus small m into capital T by 2, that is O2P. So here how to write it, this addendum circle of Pinion, small m into capital T by 2 into square root of 1 plus small t by capital T into small t by capital T plus 2 into sin square pi minus 1. So both the module will be cancelled. So AW is equals to capital T by 2 into square root of 1 plus small t by capital T into small t by capital T plus 2 into sine square pi minus 1. So finally, what is the equation we achieved? Capital T is equals to 2AW divided by so capital T is equals to 2AW by square root of 1 plus small t by capital T into small t by capital T plus 2 into sine square pi minus 1. So capital T by small t is the gear ratio, but small t by capital T means reverse of gear ratio. So what is the formula? 2AW by square root of 1 plus 1 by g into 1 by g plus 2 into sine square pi minus 1. Okay. Then here also, what is the minimum number of teeth on the minimum number of teeth on the wheel is to be finally found. At the same time, the G value, that is gear ratio, if the wheel and the pinion have equal number of teeth, then G will be equal to 1. So what is the value means? Same. 2AW by square root of 1 plus 3 into sine square pi minus 1. So if you clearly observe, the minimum number of teeth on the pinion and at the same time the wheel, if the gear ratio is 1, means the both are having the same formula, but only the addendum of the wheels, corresponding wheels, will be changed. Okay. Then coming to the problem, determine the minimum number of teeth required on a pinion in order to avoid the interference of the wheel which is in the gear with a wheel to give a gear ratio of 3 to 1. 3 to 1 means 3 is to 1. And the second one is having equal wheel. Then what is the pressure angle is 20 degrees and the standard addendum of one module for the wheel may be assumed. So addendum of the wheel is one module. So what is the thing given in the problem? Gear ratio, that is capital T by small t is equals to 3 by 1. That means small t is equals to 1, capital T is equals to 3. Then pressure angle is 20 degrees. Pressure angle means pi is equals to 20 degrees and the standard addendum of one module for the wheel. So addendum of the wheel and addendum of the pinion is there. So here AW was given, that is equals to 1 module. Determine the minimum number of teeth required on the pinion. So what is the formula to find the pinion? So what is the minimum number of teeth on the pinion for a given gear ratio 3 is to 1 at the same time for a gear ratio having equal to 1. So what is the formula having small d is equals to 2 into AW by capital G into square root of 1 plus 1 by G into 1 by G plus 2 into sine square pi minus 1. Actually, if you clearly observe, there it is the in the question they have given the wrong information. Actually, what is the given that what is the data that has given? Addendum of the wheel has given, but what is the minimum number of teeth required on the pinion? How we can calculate? Not possible. See, it has given the addendum of the wheel. Wheel means we need to find the capital minimum number of teeth, that is capital T. But what is the proportionate we are having? 3:1. But I think it is the wrong one. So in the formula we need to represent capital T is equals to 2 into AW by capital G into capital G into square root of 1 plus 1 by G into 1 by G plus 2 into 1 by G plus 2 into sine square by minus 1. So here what they have given, standard addendum of the module of the wheel was given, but we need to find the pinion. But here we are getting that a little bit of confusion like this. So they have given the wheel, but we need to find the pinion. So here there is a relation for actual pinion to addendum. So there it is. We can get the pinion number of teeth on the pinion from the addendum of the wheel also. What is the formula means? Small t is equals to 2AW by G into 1 plus square root of 1 plus 1 by G into 1 by G plus 2 into sine square pi minus 1. Okay. So where is the difference means? Here capital G is multiplied means that is a formula for minimum number of teeth on the pinion. Without that, that is for what? Minimum number of teeth on the wheel. Okay. So 2 into AW is one module by G. G is nothing but capital T by small t. What is the value? 3 into 1 plus square root of 1 plus 1 by 3 into 1 by 3 plus 2 into sine square pi. Pi is 20 degrees minus 1. So finally 2 by 0.133 that is equals to 15 or otherwise 16. So minimum number of teeth is 15. Then minimum number of teeth on the equal wheel. Equal wheel means we are having equal wheel. Equal wheel means the G value is 1. So 2 into AW by square root of 1 plus 3 into sine square pi minus 1. Okay. So 2 into 1 by root of 1 plus 3 into sine square 20 degrees minus 1, that is 2 by 0.163. So that is equals to 12.34 or 13. Now coming to the next topic, minimum number of teeth on the pinion for a involute rack in order to avoid the interference. Rack and the pinion. Rack and pinion arrangement means the horizontally there is a rack will be there and the vertically or circular one is the pinion. So rack is a horizontal that we already shown in the types of gear designs. There is a rack and pinion arrangement is also Now we need to find the minimum number of teeth on the pinion for involute rack. So the figure will shows the horizontal line, that is a pitch line, that is called the rack, and the curvy pitch circle means that is correlated to pinion about the center O. Next, t small t is equals to minimum number of teeth on the pinion and smaller with the pitch circle radius of the pinion, that is small m into small t by 2. These are the formulas we need to remember. And pi is called the pressure angle or the angle of obliquity. And AR means previously AP is there, AW is there. Addendum of pinion, addendum of wheel, and here addendum of the rack. Addendum for the rack. That is a fraction and related to the module. So we know that the rack is a part of the toothed wheel of infinite diameter. So infinite diameter means the rack, it is just like a straight line. So what is the diameter for the straight line? As we know, that is an infinite diameter. So therefore its base circle diameter and the profile of the involute teeth are the straight lines. Since these straight profiles are tangential to the pinion profiles at the point of contact, so that we can see in the diagram, and therefore they are perpendicular to tangent PM, and the point M is the interference point. Nextly, the addendum for the rack. So addendum means AR for the module small m, that is equals to, from the diagram if you see, LH, that is the addendum. LH, that is a pink color, and the blue color line which are showing PL sin pi. PL sin pi. So PL means what? OP sin pi into sin pi is there. So OP into sin square pi. So OP means small r into sin square pi. Small r means small t by 2 into sin square pi. So small t is equals to 2 AR by sin square pi. So that is the formula. So further we are solving the problem on this. Pinion of 20 involute teeth and 125 pitch circle diameter drives a rack, and the addendum of both pinion and the rack is 6.25 mm. What is the least pressure angle which can be used to avoid interference? With this pressure angle, find the length of the arc of contact and the minimum number of teeth in contact with the time. Then what is the given data? Pinion of 20 involute teeth. So T is equals to 20 and small d is equals to 125. Small d is equals to 125 mm, that is pitch circle diameter, and the addendum of both pinion and rack that is equals to 6.25 mm, and the least pressure angle is to be find out, that is pi value we need to find out. So we know that for no interference, rack addendum will be LH is equals to small r into sin square pi, or sin square pi is equals to LH by small r, that is equals to 1, and sin pi is equals to 0.3162, equal to pi is equals to 18.435 degrees. That is a simple formula. Next, what is the length of arc of contact? And at the same time, lastly, number of teeth. Okay, length of arc of contact means length of path of contact is KL is equals to square root of OK square minus OL square. So OK square means OP plus 6.25 whole square. Okay, this we can identify from the diagram. So the diagram is of the rack and pinion arrangement of this. So OK square minus OL square is equals to OP plus what is the radius? So 6.25 whole square minus OL means OP cos pi whole square. Then OP means what? 62.5 plus 6.25 whole square minus 62.5 into cos of 18.435 degrees whole square. So finally, what is the length of path of contact? 35 mm. Okay. Then the minimum, the length of arc of contact means the length of path of contact by cos phi. That is a formula. So 35 divided by cos of 18.435 degrees. So approximately that is 36 mm. Then minimum number of teeth. So we know that the circular pitch PC is equals to pi d by t. So pi into d means 125 by t. T is equals to 20. So that is 19.64. And the minimum number of pairs of teeth in the contact. So the length of the arc of contact by the circular pitch is equals to the number of pairs of contact teeth. That is equals to 37 by circular pitch is already given. That is PC. So 19.64, that is equals to 2. So finally, the minimum number of teeth is in the contact, pair of teeth are in the contact, that is 2, or otherwise that is a single pair. Okay. So and next the last one, what is a helical gear? So just we are giving the just introduction to helical gears. The helical gear has the teeth in the form of helical around the gear. So the right side diagram will shows the crossed helical gears. So two such gears may be used to connect the two parallel shafts in the place of spur gear. The helix may be right-handed on one wheel and the left-handed on the another wheel. The pitch surfaces on the cylindrical which are in the spur gearing, but the teeth is in the parallel to the axis, wind around the cylindrical helicals like the screw thread. So we already discussed about the helical gears, which may be in the single helical type, or or double helical type. In case of single helical gates, there is some axial thrust between the teeth, which is a disadvantage. In order to avoid this axial thrust, double helical gate system are used. It is equivalent to the two single helical gates in which the equal and opposite thrust are produced on each gate and the resulting axial thrust is zero. So the double helical gates are used to eliminate the axial thrust, but it is same to two single helical gates. Okay, then here what is the normal pitch? The distance between the similar faces of adjacent teeth along a helix on the pitch cylindrical normal to the teeth, which is denoted by Pn, that is pitch normal. The distance between similar faces of teeth adjustment along the helix. Then axial pitch. Axial means it is the distance between measured parallel to axis between the similar faces of adjacent teeth. It is nearly same it is of circular pitch and it is denoted by PC. Okay. If it is normally, what is the formula for PC means Pn by cos pi. But here alpha is the helix angle, then the circular pitch is equals to P normal, that is Pn by cos alpha. This helix angle is also known as spiral angle of the teeth. It's a very important helix angle, that is alpha may be denoted as spiral angle. So with that, the entire topics of the gates and the gate lines, what are the types of gate lines available or gate teeth are available. The mainly important thing is the length of path of contact and the arc of contact and the minimum number of teeth on the wheel and the minimum number of teeth on the pinion. So these things we learned from these gates and gate lines classes. So with that, the gates and gate lines topics were fully covered. So for understanding, you need to see the classes is more number of times so that we can easily solve the problems. Thank you.